recording. A good day, everyone. This is Ram Posham. I will be doing a quick overview of Oracle RAC database. Very quick overview. Hopefully everybody knows about this. I wanted to do this before I do the actual demo. So that's what I will do. So let me get started. So RAC is a very unique technology for Oracle. I think all of you know. This is how we differentiate at the database level. I mean, lots of customers love Oracle. I mean, a lot of financial customers love Oracle. They use it. For example, I used to support Bank of America. They have an installation base of about 200 Exadata machines and thousands of databases. They initially thought they will use Oracle RAC for only tier 0, tier 1, very mission critical, but nowadays they are using for everything. So just want to give you background. So it's essentially a shared everything architecture. You got all this shared storage, you got a database server compute nodes, and you have your application that is connecting to the database. So if it's a multi-node rack, for example, if it's a Exadata full rack, you got 8 compute nodes. Well, in the cloud, it's all elastic. So it could be 8 or 16. So when you ask for, let's say, 100 connections, they will be spread out across all these compute nodes. So if you lose a node or two, doesn't matter, as long as at least one compute node is available, your application will continue to run, right? That's the value of Oracle database, RAC database. So RAC gives you a bunch of benefits: scalability, availability, performance. I mean, again, scalability is what if with one machine, you're able to do 100 transactions per second. With 2 machines, you should be able to do twice and so on. Availability, I just explained that. Performance is specific to queries. If a query takes, let's say, 10 minutes on 2 nodes, and if you expand the RAC query to 4 nodes, it should take half the time. That's basically spreading the parallelism. So that is performance. Workload management is distributing the work. You can say first 2 nodes, I want to run transactional workload. Third node, I want to run ETL workload. And 4th and 5th, maybe a reporting workload. And you can do that by the concept of a service. You define a service at the database level. And when you connect to that service, your connections will go to those database nodes. All right. So those are the key benefits if you want to remember benefits. Now, RAC provides you application continuity, right? Well, without RAC, until 18C release, this was the behavior. So let's say you have an application user sends a transaction, right? And it goes to the database from the application server. And imagine the database commits the transaction, and just before it acknowledges back to the application server, it's an edge case. It can happen, right? The database committed, but it did not communicate to the application server because of some failure, maybe network or maybe a database node, any of that. And when that happens, what happens is this application server says, hey, I lost the connection, and it will redo the transaction. Typically, because once it doesn't know that the transaction is committed or not, it's going to re-execute the transaction. Well, it will not, under normal circumstances, until 18C, you will not be able to do that. So what happens is it gets an error, the user resubmits the transaction. So whether you are placing an order or if you are doing a money transfer, you will be redoing the transaction because you did not receive the acknowledgement of the commit. That's how it behaves until 18C database, okay? But after 18C onwards, we do something smart. That's what I'm going to describe in just a second. Any questions on that? I mean, if you are on the receiving end, for example, somebody transferred the money, you got it. If you get twice, right, you are okay. But the person who is transferring the money, what this means is that person will be doing the transferred twice, right? Or you may be asked to pay the money 2 times because of this kind of error, because of this kind of edge cases, there could be duplicate transactions, all right? That was the case until 18C. This can happen in any database, but it will not happen in Oracle database starting with 18C. How? So let me go through that. So there is something. Yep.
This is TSE is different from TIF, right?
Yeah. Transparent application failover, is just a technique that we use for selects. So whenever you run a query, the query will get a SQLnet level, you get an error, hey, connection lost, and it will re-execute the query, throw away all the rows that were already returned, and it will give the next set of rows. That was called transparent application failover. That was only for selects. And whereas this one is for actual transactions, DML, inserts, updates, deletes, all that. It's a real transactions, not selects. So this also does for selects, by the way. Starting with 18C, we do this for everything. Selects, inserts, updates, deletes. Make sense?
Okay. Yeah, but Ram, I guess even with TAF, what happens if there is an active DML transaction? If it is a Java database connectivity, what happens is the transaction gets rolled back. And of course, connectivity goes to a surviving node in TIF. That's the behavior.
Correct.
So I guess TSE is something very new, right? With the 18C and onwards.
Correct. So here is the thing, right? You remember that edge case, the transaction is committed, but before it sent the acknowledgement to the application server, something failed. The application server does not know that the transaction is committed. So what it does is the user gets an error and the user resubmits the transaction. That is the behavior until 18C.
Oh, okay. Got it. Got it. Yeah,
that is the edge case. So that's how it results in duplicate transactions. Okay.
All right.
Now in 18C onwards, what happens is it's very smart now. What happens is this. The transaction goes here and then it goes here. And then when it comes back, it gets an error, right? Hey, now your connection has failed over to the surviving node here. So what this application server does is, hey, database, I lost the connection. What happened to my previous transaction? The database will say, yes, the previous transaction there's a unique transaction ID, by the way. Whenever you use this latest drivers starting with 18C, it keeps track of the transaction ID. What happened to this transaction? The database says the transaction is committed. And if the database says transaction is committed, then this will return saying that, hey, the transaction is committed, everything, life is good. You will not get that error. Now, you may say, hey, I did some work here. I did not commit, but I lost the connection. Then the application server, what it does is it replays those transactions. So let's say it was insert, update, insert, and before you committed, what happens is you got an error. So instead of asking the user to resubmit the transaction, one smart thing the application server does is at the connection pool level is it replays those transactions like insert, update, insert, whatever you did, right? If your transaction was consisting of 5 things, and if this error happened after 3 things, those 3 statements will be executed by the application server to the database after the failover. So those are the things. So that's why it is called transparent application continuity. That means you won't even realize that the database had a connection problem or a node failure or a network failure and it failed over. You won't even notice that. That is the beauty of transparent application continuity. Make sense? Hope it, again, if you have any questions, again, let me know, but that's the beauty of this transparent application.
So Ram, would you be giving a demo on this?
Yes,
like,
yes.
What?
Yes.
Oh, awesome, awesome.
Yep, I'm going to do that. So there are some white papers here, and the way it works is this, right? So
Mhm.
RAC and transparent application continuity. So you got application server, you got, I'm just looking at a Java application. Now here I'm saying DB driver, but it could be a Java JDBC driver, it could be OCI driver, it could be .NET driver. This is applicable for all the drivers today. So here is the thing that I was talking about. At the database level, you can create different services. You can create sales.oltp, ship.oltp. So depending upon that, this service is nothing but grouping of the instances. So whenever you create a service called sales.oltp, how do you do that? You run a command called srvctl, create service, blah, 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 all that. And you provide the node instance names, instance list. And also in the case of 12c onwards, you also provide the PDB name. So that's how you define the services. And here you've got connection pools. So what happens is at the rack level, there is a messaging mechanism. So whenever there is anything, an event happens, it could be a node failure. It could be a message related to the load on these instances. So constantly, the grid infrastructure at the database level is sending the messages to the middle tier using what's called FAN, fast application notifications, all right? So whenever there is a node failure, for example, this messaging mechanism, which is part of Oracle Grid Infrastructure, which is part of RAC, it informs application, the middle tier, saying that this node went down, and immediately the connection pools are cleaned up. Okay, so it's not going to send any request to this one, and all the connections will be failed over to this existing surviving instances. That's how the middle tier, the connection drivers do that. So the application level, you just say, give me a connection, do the transaction, and after the transaction is over, I return the connection back to the connection pools, right? Now, for achieving transparent application connectivity, the application server need to work with connection pools. It will not work with single connections. It works with only connection pools. So this is how it works. Now, once the server comes back up, and I should say, once the server comes back up, the connections will be automatically balanced. How? Because of this messaging mechanism. Once the instance comes back up, it sends a message to the middle tier saying that, hey, this instance is up. Now you can send traffic to this one. So that's how the integration works between the RAC database and the application server. We provide all the integration through the drivers. Oracle provides the drivers that are integrated with RAC. Integration means what? That means if any event happens, it gets notified. And if there is any instance that is heavily loaded, it knows how to route the traffic. So connection load balancing and also the workload balancing, a lot of other things happen. I'm not going into all the details, but that is the power of integration that we achieved between the application server and the RAC, all right? Now, these are the JDBC drivers. I just took only the JDBC drivers, 19C, these are the drivers, OJDBC.jar, all that. And 18C, these are the drivers. Now, when it comes to this RDBMS interoperability, 19C JDBC drivers can go across 19C database, 18, and all the way up to 11.2 database. So we provide you downward compatibility as well as upward compatibility. If you got a 11G JDBC driver, it can access 19C database as well as 11.2 database. So we provide upward compatibility as well as downward compatibility. Now, when it comes to TAC, transparent application continuity, you need to have this combination. That means you need to be using JDBC driver 19C or 18C. And this transparent application continuity works with 19C database and 18C database. You cannot have transparent application continuity with 12.2 or 11G database or 10G, you can forget about it. But does this make sense? So if a customer is saying, I want transparent application continuity, they should be using 19C JDBC driver or 18C JDBC driver and 18C database or 19C database. They cannot be using these drivers and older versions of the database.
Ram, I guess I have another, I hope it's not a stupid question, but out of curiosity.
Yep.
You mentioned this is Oracle WebLogic Server. This comes pre-configured.
Correct.
So I'm assuming that this is is it only for WebLogic, or can this feature be enabled if the application tier uses any other like Tomcat or Apache, etc.?
Great question. Great question. Thanks for asking. Actually, I should have qualified here. Initially, when we started, it came with Active Grid Link, but now it's pretty much available with the WebSphere. It's available with Tomcat. So yes, it is available with other application servers too.
Okay, so
Yep.
this technology can be implemented across any other application. It need not be just Oracle apps or WebLogic. It can be for any third-party applications as well.
Yes, 100% correct. Yep.
That's good. Okay, thanks.
Yeah, no problem. Thanks for asking. That's a good question, actually. I should update this presentation. So now demo setup, this is how I have. So we have, it's 4:48. I got only 12 minutes. I wanted to do this only in 30 minutes. Let us see whether we can do it. So this is the rack. We just talked about it. And when you go to cloud, when you're provisioning RAC database, there is something called a client subnet. And this is the application subnet. And there's also backup subnet, which I'm not showing here. Now, in our tenancy, this tenancy, I have a database in Ashburn, Virginia. This is running on Exadata cluster service. It's a 2-node rack. This is the rack nodes private IP, all right? And this is my bastion, all right? So this is, I'm going to be running all the demos from here. And this is I will connect to this rack and so on, okay? And this database has a database called RP sales underscore RP. This is the unique database name. And inside that, there is a pluggable database called sales. And within this pluggable database, I'm going to create a schema called a swing bench order entry, SOE for short, okay? And all the things I'm going to be doing it from here. All right. So the demo, there are 3 demos. One is the transaction demo. That means in the middle of a transaction, right? I'm going to shut down one of the instances to simulate patching. The planned downtime is a big thing, right? Every 3 months, Oracle releases a patch. So customers have to patch the RAC databases. So if you are using RAC, you can do it in a rolling fashion. So patch node 1, then bring it up, then you patch node 2 and so on, right? That's what you do. So I'm going to simulate that scenario here. Same thing for, well, we can do it for unplanned also. That means in the middle of a transaction, your database shuts down or aborts. That's another one. And we can also do for select operations. So all these things I'm going to do in the next few minutes. Okay, so that's the demo. Now, you may be wondering, how I'm going to be running all the scripts. So what I've done is I've used a spreadsheet technique actually. So in the spreadsheet, you see this one. This is my bastion IP. This is my unique database name, my database name, and this is the pluggable database name. And this is my scan name. No, not scan name. This is the service default service name that is created when I create the database. Now I want to create a custom service with an extension of .tac. And this is the name of the service name. So this is basically what I'm doing is you can see custom. I'm using the database name. I'm appending this. So you see, I'm just using the Excel spreadsheet functions. You will see what I'm going to be doing that in just a minute. This is my rack node 1. This is where I have my private key on my local machine. And this is my scan name, port number. And this is my TNS entry in the tnsname.ora. And this is my username, password. I'm going to create a swing bench schema called SOE. And these are the passwords. And I will be using, I don't know whether you folks know a tool called SwingBench. It's a free tool. So that's what I'm going to be using. And this is the table space name. And I'm going to be creating connections with 50 connections to SwingBench. And this is the SwingBench configuration file. I want to run SwingBench for 10 minutes. And this is my custom SwingBench file. So just bear with me, don't get lost. These are just the input to my demo. The reason why I'm doing this is tomorrow, if you want to do the same thing, you can just update these things and you can do your own demo, because all the scripts are automatically generated from this input. So I'm just using the spreadsheet for that. Now, go to here. So what I'm doing is I'm opening a SSH connection to my Bastion. At the same time, I'm also opening a tunnel to my rack node. See that one? So this is what I'm doing. This is a tunnel to my rack node. This is the connection to my Bastion, and this is my key. So this is automatically generated for me using this input. Whatever input I gave, I generated this string using this Excel function called concatenate. Okay. So I've just copied this and I'm going to paste it here. Okay. So see that I'm connected to the Bastion now. I hope you guys can see this because I'm using a big monitor. If anybody wants me to increase the font size, I can do that. All right. Then the next thing that I'm going to do is, so this is called Bastion window 1. All right, let's call that. Now I'm going to just I'm going to install SwingBench actually. See this one? I'm generating all this. So I'm just going to copy this and I'm just going to paste it here. So what it's going to do is actually it's going to download SwingBench tool and it's going to unzip it. That's what it did actually already. Now I'm going to go to the rack node. How do I go to the rack node? This is what I do. I log into the rack node. This is the connect string. That's the SSH string through the tunnel, right? This is the rack node. Then I'm going to create a service. All right. I'm going to create a service called sales.tac. And if it's already there, I just want to delete it. So I'm setting the environment. I am removing an existing service and I'm creating a service and checking the status and starting the service and all that, right? I'm just sleeping for 10 seconds for a reason. Actually, if I do it instantly, there's something I was encountering. But anyway, so that's what I'm doing. So what I'm going to do is I'm just going to copy this script and run it actually in this window, all right? In this window, paste it. So what it's doing is it's removing that service, it's recreating that service. That's all it's doing. Then after that, I'm going to create a tnsname.ora file. Again, those of you folks know Oracle database, you need to have tnsnames.ora if you want to connect to the database. There is another way of connecting to the database using easy connect string, but I'm just using tnsnames.ora. See what I'm doing? I'm just echoing this string into this file, right? Into this file. So that's what I'm doing. So see this, I'm just copying this and putting it here, pasting it here. So it generates a local file here. See this? I did a cat of this, and this is the file I created. The next thing is, I want to show you how many pluggable databases are there. So what I do, I go to, again, the same window, I'm connecting to the database, and I'm saying, give me all the pluggable databases, just the names of the database, pluggable databases. So, okay, so if you see this, there are few pluggable databases. Sales is one, there are a couple of other things, but for our demo, we are going to be using this pluggable database. So I just want to show you that. Then you can also use, by the way, this syntax also. This is a easy connect string. This is a TNS names based connect string. So if you want to do that, that's fine too. This is a probably better look. Okay. So this is the pluggable database that I will be using. Then the next thing I'm going to do is list pluggable database, we did that. Oh, sorry, list DB services. So I'm going to just go to the rack node. By the way, whenever you see this red border, that means I'm running in the rack window. So it just shows you that there are a bunch of services running. So, but our thing is the important one is this one. See this service? This is running on two nodes, node one, sorry, instance one and instance two. That's what you see. Then what I'm doing is I'm creating a swing bench schema inside the database. How do you do that? Just copy this into this window one. This is how it creates a SOE schema inside the pluggable database. So just copy this, paste it here. So it's going to run this swing bench tool in the character mode. It takes about a minute or so to create the swing bench schema. All right, I got only 2 more minutes. Let's see. I may need another 5 minutes. What I'm going to do is I'm going to share all the scripts. You folks can look at it and understand it at your own pace. But hopefully it's not that confusing, right? So I'm just creating the schema inside that pluggable database. Then the next thing I'm going to be doing is I'm going to create a swing bench configuration file called this one, OPC in the directory, SOE tag config file. Now, the swing bench tool uses a file and it captures all the, how many connections you want. So by the way, this thing that I ran, it creates a schema. It loads a bunch of tables with some seed data. Now I'm going to be running the this one. Okay, so let me create this. I'm just doing an echo. You see this one? And creating that file. Okay. So just copy this, put it here in this window. It is not doing anything but just creating this file. So if you want to know what this is, cat, this, right? So that's all. It just created this file with all this connect string. Where is that? Let me just go here, up. See this one? It created with my host name and the driver type, the username, password, all that is here. So that's what it's doing. Then the next thing I'm going to do is I'm going to start a workload. Okay, so it's like a OLTP workload. So I go here into the window one and run here, right? So let me go here. So I'm just going to copy this and paste here. So what it's doing is, you see this one? It is running this tool in character mode. It is passing this configuration file, and this sets about 10 minutes. I mean, we can kill this by Control-C, and this is the number of transactions per minute. This is the number of transactions per second. Now, you want to know, is it really doing something? You can count the number of rows. So here in this other window, right? So open another window, go here, go to this window, right? I'm opening another window to the Bastion. And then I'm going to be running this. Okay, I'm exporting TNS thing. I'm running, connecting to the database. I'm selecting the rows in those different tables. So let me just show you that. See this one, customers table has got 103,839. Now, if you want to wondering, is it really inserting the data? You see this one is going up because that tool is running here, all right? And if you want to see that, again, see, it keeps going up, correct? So now you may want to know how the connections are distributed across the rack nodes. So go here, you look at this. How do you find out the connection distribution? So this is a script for that. How many connections are made to each instance? So paste this. See this one? Instance one has got 23 connections. Instance two has got 27 connections. It's pretty much equally balanced, but over a period of time, they will get balanced out actually. All right. If you wait for 10 minutes, maybe you will see them equally very well balanced. So that's how it looks, the connection load balance, right? Now let's go to the next one. Now this application is running, and this is how the connections are distributed across these rack nodes. Everything good, looks good. Now this is a patching time, right? Customers want to patch the machine. We want to simulate that. How do we do that? We need to shut down the instance. So this is what I'm going to be doing. I'm going to log into the rack node. By the way, my convention, as I was telling you, if you see this red box, that means this script should be run in the rack node. So just a notation I thought I will use. So I'm going to see this command, which is generated by this concatenate and all that. So use this script, run it as Oracle, basically. That's what I'm doing. So here I go and just what I'm doing, I'm stopping this instance too here. See that? I'm stopping that instance too. So let me just go and paste it here. I'm shutting down that instance immediate just to simulate patching. Okay, now I want to shut down this instance, and after that I'm going to be doing the patching and all that. I'm not going to be doing patching today. That means it's going to take, right? But just to show you, the use case. So it takes, now while this is going on, you see nothing is happening. It's still moving. The workload is happening, but you go here, this window, it is still the connections are there. Why it is, oh, you know what? I have not done that. So I have not copied this quote. I did not copy the entire script. That's why it is not happening. So let's see, paste it here. Oh, come on. I didn't copy this whole thing. Okay, one more time. Okay, let's paste this. That quote was missing when I copied. So now it is doing it. So now you go back here. See this? Connections are dropping because we are shutting down instance 2. You see the number of connections dropping. It will go to 0 on that instance. See that? Now this will be disconnected completely. Now look at the left side. The application doesn't even know that the database instance has gone down. See, absolutely no change. You still have the throughput, right? Now you want to believe that? Okay, let's go to query connection distribution. We did that. If you want to know whether this is still working, see the row counts. So let's copy this, paste it here. See that many rows are inserted, still going on. 123,885. See this? So the application is just working just fine. You're following with me? And the instance is shut down. All right. So shut down, the instance is done. We did the connection distribution just a minute ago. This is the connection distribution. Right? So it's still 50 connections. Now what we'll do is we will restart that instance, right? Now the patching is completed. Let us restart the instance. I mean, assume that the patching is completed and we are going to restart the instance. So now while this is restarting, the connections should, well, they will go up only after the instance restarts, right? It will not connect if the instance is not ready. So only when you see the dollar prompt here, then you will see some connections going up. So you need to wait for a second. Now, while this is starting, nothing is happening, no change to the application, right? It is still continuing. All right, so the instance started. Now you go back here. See that? You are with me? Everybody is with me so far? See that the application is running just fine. And if you want to know, again, the throughput, you can see the connections are just sorry, the data getting inserted. So that completes my first demo. Folks, any questions? Was this okay, or somebody tell me this was clear enough?
Hi, Ram. Great demo. Thank you.
I canceled this. Okay.
I'm just wondering,
Yep.
Ram, you hear me, right? I'm just wondering if we did a similar exercise, but
Yep.
using TAF, not TAG, TSC, right? What would have been the outcome?
Oh, you would have seen all these errors here. Simple. I mean, you would have seen connection errors. This will not, you will get a connection error. Basically, the transactions will be disconnected. There will be, you'll be getting a lot of errors.
So the whole, okay, now I think it's getting more clearer.
Okay.
The application was able to survive the
Yep.
node going down.
Yep.
No errors were seen at the application layer.
Exactly.
It's transparent.
Yep.
But with TAF, probably, it would have errored out whatever his load job. It's
100%.
just not doing as a load job, right?
Yep. Yep.
Yeah, that makes sense.
Okay, so that is demo one. So in the interest of time, let me go to the thing. I did the connection. So now let us do the DML real. I mean, this is even simpler, easy to understand. So what we'll do is, this is go to, where is the, okay. So here in window one, I'm going to log in as SQL Plus. So go here, paste it. See this, I logged into just SQL Plus as SOE, right? This is easy. Now there is a table called customers. So I just want to show you. So that is a customers table, right? You see customer ID, all that. Now, what we will do is we will insert a row into that customers table. Customer ID, customer first name, all that. That's all I'm entering here. Now, this is the SQL that I generated, right? Using the same concatenate function. So just take this. Again, the reason is if you want to change any of these things, you can do that. I can put maybe somebody else's name just for fun, right? Customer's name or something. So take this and you insert here, okay? Paste it here. So what we did was we inserted the row, then I did a select. So that's why that is a select here, right? So if you see this, that's a select. I can run the select one more time. I did not do a commit. See that? I did not do a commit. Now, we don't know to which instance this session was connected to. So what you do is go to this window 2, find out to which instance that connection was made. So go here, paste it here. See that? It is connected to instance 2, just one connection, right? So this one is connected to instance 2. Now what we are going to do is, it said find out which instance it's connected to. By default it is 2. Actually, what I did was if you want to customize, let's say this was connected to instance 1, then you can change it to 1. The reason is I'm using this for generating the next SQL, next command. So you take this, what are we doing? We are shutting down about that instance. That means we are in the middle of a transaction and we are shutting down that instance, shutting about, right? So I copied this, I go here and shut down that instance. Paste. Okay. So that instance is basically gone, right? It will be gone in just a second. Now you go to this, it is still working, right? So that it is still listing. Now the question is, where is this coming from? Is it coming from instance 2 or instance 1? Well, wait 1 second. Once this gets shut down, we will run the same SQL and see whether it still works. See, that is done, right? It is shut down and the rack is instance running only on this one. So let's see whether this runs, right? It works fine, right? It still gives me. And here, now we want to know to which instance it's connected to now. See that? It was 2, now it is instance 1. This transaction is still safe. Do you want to commit or roll back? You decide. Somebody tell me whether I should commit or roll back. I can do either. Somebody?
Great, Ram. Either way, it doesn't matter, but it proved what it's supposed to do.
I just want to engage you guys.
No, that's fine. That's fine. It did the job. This is awesome. I had no idea this feature is there. Wow,
So
this is amazing.
Now what you do is you restart that instance just for this one. So go here, paste it here. Just to, so you do that. Again, what are we doing? Now, just to repeat the demo, you can, again, once this thing comes back up, actually you can run this while that's going on. Just to repeat the demo, actually, we want to delete that, right? So because it's committed, I can just go back and paste it here. Committed, folks, okay, just hold on. Oh, you know what? This is by itself, so I need to, you
need to go out of the SQL Plus.
Yeah. Correct. Otherwise, I can just copy this actually.
Copy only the.
Yeah, that's right. Only awesome. This one. Yep, that's right. So let me paste that. No. Okay. What happened to this? Okay. Let's go back. Exit. This is concatenate. Oh, you know what? This one is, this is not concatenate statement. So that's the problem. So let's go back here. So it's not complete script. We did a select. Oh, okay. Same thing, right? Why it's not working? The number is same. Let me just run this again. This 0 rows deleted. What happened? We did commit that transaction. So let's see. This one was working. So let's see. That magic is okay. Paste this. Did we delete that row somewhere? I mean, I don't know. Oh, row deleted.
Commit. Yeah.
After that, we deleted actually. Yeah. We committed, but we also deleted later. We actually, so when I copied that SQL, it had an issue with this line, but it did this. It did work actually. So that's why you see this one.
Yeah. But what is, this is the end of the demo, right?
This is the end of the second demo. Yes.
Yeah. It did the job, what it is supposed to do.
Exactly.
This is good.
And the last one, very quickly, select, right? So select, so my estimate of 30 minutes is not enough. So go to window 1. Let me get out of this. Let me repeat the demo. Let me do the new demo. So go here, this is for the select. Is this, you're here. And now what you do is you go here for this one. I'm selecting the array size as 5,000 rows and then set pause on, all that, right? So do this, paste it. See this? So it fetches the rows. Now, I didn't want to select tens of thousands of rows before killing it. So it is just paused there. So now you go here and find out to which instance it got connected to.
Yeah. I think Dr. Ram, you're going to shut down the other server now, the server, which in this instance, and that
you got it. Exactly.
To work.
Yep.
Okay.
So here, what we are doing is we found that, wait for this thing. Okay, did we shut down that instance? We are going to shut down the instance here. Yep. So here is the shutdown of that instance 1. Is it instance 1? No, this is instance 1, right? So we need to change this to instance 1. Now we are going to shut down that instance. Go here in the middle and paste it here. All right. This is for select. So And while that is going on, we can still continue this. The rows are still coming. And let's see, once it's shut down, what we'll do is we'll go to the window here and this, select from dual. Okay, sorry, this one here. So that is gone. This instance is gone. You got all the rows and you just paste this equal. See that date, and here you go and find out whether it failed over or not. See that? It failed out to instance 2. And that's pretty much it. Actually, I wanted to show you those many demos. And if you want to restart that instance, again, you can go here, completion.
Are you planning to give this as a demo you have with the customer, Ram, or?
I use it, yes, for customers. And I'm going to share everything that I did today to everybody on this, whoever attended, okay?
Okay.
So that's pretty much completes my demo. So I planned for 30 minutes, but I took more than 45 minutes.
No, this is awesome. Thanks, Ram. Thanks a lot.
Okay. Any questions, friends, folks on this call? Others? Was it any feedback? Let it put that way. I mean, do you think we can improve this? I wanted to do it in the shortest possible time.
Ram, this is very explanatory, but I've been a DBA my entire life. Okay. But probably to a end customer who is not into database or being a DBA, you may want to incorporate into such kind of demos using maybe a SQL developer as a front-end tool. Connect through that and show that, okay, here I run this transaction, I do the select, I do this insert, this is from a SQL developer. So the front end, if you keep a SQL developer, it would rather, he can visualize it more clearly. Okay, I'm hitting a transaction or I'm sending a transaction through SQL developer tool, and I'm talking to that's it pretty much. It's more for better visualization.
I see. Okay. All right. Any other feedback? Thanks. Thanks, Hassan.
Sure.
Yeah.
Thanks, Ram.
Any final questions, folks? I'm going to shut down otherwise. Thank you. If you don't have any questions, you have a good day. And if you have any other questions, reach out to me offline. Thank you. Bye-bye.